Testing 1 2 1 2 check. Testing 1 2 1 2 check 1 2 1 2. Testing 1 2. Testing 1 2 check. Testing 1 2 1 2 check. Testing test.
Podium microphone testing 1, 2, 3. Podium microphone 1, 2, 3. Do you think we It's going to be difficult. I thought that you were going to do the selling, not me. Okay. Okay. So we are going to talk in this talk about the one part of the WebRTC testing that it is has been not very handled until now. I mean that it is the simulcast, testing the simulcast part of WebRTC. I mean, up to now, most problem. I mean, there are several layers of testing in WebRTC, from going from, as also Alex explained the other day, going from the unitary test done by each vendor browser, also the WebRTC compliant testing, and also the latest one is the end-to-end WebRTC browser integration test that consists mainly in testing how are the interoperability between two browsers. As you can see here, the typical the architecture of WebRTC has different interconnections layers. You have the WebRTC layer, the JavaScript API, that it is posted from the browser to the application, and also you have all the IETF protocols. So when you are doing end-to-end testing with two browsers, what you are typically testing is the JavaScript API compliance, but you are not doing the IETF compliance to the spec. I mean, you can do it indirectly by checking the statics and checking that what you get is what you are supposed to do, but you cannot test 100% that the compliance of the browser with all the IETF specs. So you cannot check if the browser is doing NAG, you cannot check if the browser are doing RTX. You can check that what are the amount of lost packet and how the video behaves with that with that packet loss. But you cannot be 100% sure that what the browser is doing is what it is supposed to do. I mean, most of the times it is just enough with doing that. But if you are going to do going to test simulcast, the main difficulty is testing all the IETF protocols, because the JavaScript API is really low for simulcasting. Also, the main problem with this approach when testing simulcast is that the browser are only intend to be to implement sending simulcast layer, but a browser does not support receiving simulcast layer. So there is no way that we can just test WebRTC simulcast just by testing browser to browser, because browsers are not expected to receive a simulcast layer. So what's the logical step in this? If you follow this approach to do next is, well, use an SVU. I mean, what you are going to try to do is just to get one of those SVU that are available and check the integration between having the browser running against this SVU. But here you have several problems, I mean, because the SVUs mainly what they do is they terminate the ICE, the DTLS, the RTCP, and RTP. So you are not doing end-to-end testing, because the end-to-end is between the browser and the SVU. So if you test, for example, Chrome against your favorite SVU, against Firefox, you are not going to test Chrome with Firefox, but you are going to test Chrome with SVU, and you are going to test the SVU with Firefox. So you have two legs that are interconnected, but you cannot do completely end-to-end. Also, well, the SVUs are meant to be used, so they typically already has hacks and works around for all the known browser bugs. So if you are going to test one browser with another browser, it is going to work because the SVU developers already are spending a lot of time fixing and discovering all the bugs and how to work around them. I mean, they have been able to give very good quality in the SVU with all the known bugs of the Chrome browser. So you cannot use those SVUs for discover these bugs. Also, it is difficult to test error cases. I mean, again, the SVUs are meant designed to work, not to fail. So if you want to test some error cases, or you want to test how the browser works if someone sends them sends an invalid thing, you cannot do it easily. I mean, you can try to emulate the network condition between the SVU and the browsers to trigger this kind of errors, but it is difficult. And also, integrating this into any kind of test suite is complex and difficult because almost all SVUs, what they provide is just a full UI, so you can use it directly. And so it is going to be either costly to recreate that UI or create one of your own. So it is not really trivial to integrate this to create these test cases that WebRTC does. So what's the idea behind testing using Meduse for doing simulcast testing? Well, the SVU media server, what it is an SDK mainly. It is not an end product, so it is mainly an SDK, a media server SDK for WebRTC that has a Node wrapper, and also is going to have a Java wrapper. So it allows you to create services on top of that. So with that, you will be able to create custom tests using the media server, just not only let's say the full SVU, but you can create single testing. So just to create what happens if you send two layers and you do layer select between one and the other. You can try to create individual tests for each of these ones without having to worry about the UI or whatever, because you implement it on your own. This will allow you not only to test the WebRTC APIs that are already tested in the compliance suite, but will allow you to test all the IETF protocols, because as the media server have access to all the RTP, RTCP specs, we will provide the stats, and we can create ad hoc checks to ensure that what we receive is what it is supposed to be sent by the IETF specs. Also, we can force to emulate different error conditions, but for example, we can introduce packet loss, or we can introduce, we can just close the DTLS connection. We can emulate some kind of error condition without having to do tricky things in the networks and in the network, or trying to have to set up a network emulator to implement this thing on the wire. You can do it directly on the SVU. So, and most important, that it is with as we are, our intent is to test simulcast. We can develop specific testing for simulcast. I mean, it is being able to test, to create tests that sense different simulcast layers and start switching between those layers, check that the IETF specs are compliant, and also send one of those layers back to the browser to check that what they received is what it is expected to be received. For example, there has been a recent, well, have been discussed with the LibWebRTC guys about if it was needed to rewrite the BPA and the picture ID when doing temporal scalability. So most of the SVU today already rewrite them, because if not, Chrome will not display the video correctly. It will do it at a lower frame per second, because it will because it expect the jitter frame buffer expect to receive continuous picture ID, and if you just, for example, do temporal scalability in one of those simulcast layers, it will consider that there has been packet loss, so it frees. But for example, you cannot do it with a commercial or a ready-to-deploy SVU, because they already hack this and they rewrite the picture ID, that it is something that was not meant to be done. I mean, or it is not supposed to be done. So these kind of things you can only test if you control what, let's say, the SVU or whatever you test the browser with. So this, for example, is that this also you can check with if you are doing simulcast. Today it's only supported with BP8 and Chrome and Firefox. You need to check also not that even the BP8 stream is correct. So this is only, you can do it if you control the SVU. And also one thing that I think is good compared to integration tests is that you can have deterministic results. Because even if you are doing end-to-end integration testing between two browsers, the thing is, I mean, and even you program network loss on they are random. So you cannot have the same behavior. You cannot say, you cannot control when you are going to drop a packet. You cannot check, for example, if you want to drop a packet after an iframe, or so you can create this kind of tests and get deterministic results if you implement in a specific SVU that you use for testing. So, and also one thing that it is important is that you cannot do that if you don't have a commitment from the SVUs or the media server, whatever you are using, to keep on track with all the changes in the IETF spec, and also commit to this testing, because as I said, the focus of the SVU is to provide a commercial viable service. So they are not worried about failures. They fix that failure. They not on purpose make their SVU works just because there is a bug on the browsers. So I think that's why it's important to have something custom or ad hoc implemented for testing WebRTC with simulcasting. And you cannot use any other commercial or the SVU that has pressure to have go live, because what they will and their main interest will be, of course, in to provide good quality to their customers or to their users, and not to fail if there is a problem. And also, as I said before, the good thing is that as being a Node.js API, you can integrate this with either control it from the browser, so you can have custom tests running completely on the browser, or you could integrate it into a Selenium or whatever. So you can have both browsers, browser and the SVU controlled by the same test suite. So I'm not sure if I have been too fast, but this is all they have for today. So if anyone has any question or. Yeah. Yeah. One or two.
Okay. So just a quick question. So as you mentioned, the testing compliance with W3C and IETF specs as a part of the, what it allows you to cover. I assume you probably already contacted those guys or are in touch with those guys. Are they interested to probably use that to some extent to check the compliance on their side as they work on the specs or something like that? Because typically they themselves want to come up with at least some sort of the test suits or something like that. So I think that will be a win-win, potentially win-win situation.
The only thing is that the W3C compliance spec are typically just running text on the JavaScript API. So I don't know if how difficult or easy it will be to integrate also a different entity just to run simultaneously, because, for example, the simulcast that is the people from Cosmo doing they tested the API, so you check that you can set the sender, the parameters to enable the simulcast, and you get the expected results. But I don't think that the WebRTC the W3C compliant testing can go further than that. You need something else to ensure that not only that the JavaScript API is returning the correct values and give you query the parameters for the encodings, you get what they expect, but also that the RTP streams that are sent on the wire are correct.
Fair enough. Yeah.
To answer your question a little bit differently, Vlad, part of the W3C spec in WebRTC 1.0 is the simulcast. It's half a simulcast, right? So it's only sending, and so you need an SFU to test that. That was not very important to the browser vendor before they put the RTP sender and receiver in there, which is the case today, and it's very recent. So the interest are surged a lot there. Right. And the second thing is, since it's part of the WebRTC 1.0 spec, it also need to be tested for the entire spec to reach candidate recommendation. So we had a specific meeting with the editors of the spec, so Bernard Aboba from Microsoft and Stefan from Ericsson. And Bernard's feedback was really interesting, is that most of the normal one-to-one stuff he can deal with, but testing all the corner case of the simulcast is difficult, specifically because most of the questions he had were specific to a given SFU. So it was not why simulcast doesn't work. It was why simulcast doesn't work with Janus, why simulcast doesn't work with Currento, why. And so emerging from that was the question of having a reference SFU implementation to be able to test along. And I'm sure you're very well aware of the Coturn project. So the Coturn project is a fantastic piece of software, and not only because they took a very, very hard approach on testing. So they have actually a lean and mean flag of the Coturn, where the server is only implementing what is in the spec, and that's it. Where some other SFU, some of those, sorry, because Turn is not an SFU, right? Coturn is not an SFU. Some other project will take a much more practical approach and say, I need to work with Chrome and Firefox today. So now I'm going to mangle the SDP to be able to handle Plan B and Unify Plan at the same time, and so on. So Jitsi, for example, has a very practical approach. Maybe you heard Boris the other day telling you, we actually injecting frames in the data in the stream to bypass a problem, an existing bug in Chrome, because it needs to work in production, right? And so there is always that compromise there. And most of the projects today are doing the practical approach and not the lean and mean approach.
Well, if you want to have users, you have to take the practical approach.
No, I understand, but Coturn has user,
yeah.
right? So Coturn managed to, is an example of a project that managed to have both at the same time with a very, very focused coding. And so we're going to have a special meeting before TPAC around the 2nd or 3rd of November, specifically on that topic. How do we approach the testing of simulcast? Which SFU should we use for that, at least in the medium term, and so on and so forth.
Mm-hmm.
I have a question about how to configure, how to create a test case with the media server. Yeah.
Yeah. Well, the Medusa Media Server is an SDK, so it allows you control the low-level objects in our WebRTC stack. So it allows you to raise a DLL transfer, to set the ICE connection, to create new streams. So obviously this is a work ongoing. This is not ready at the moment. So the intention is to be able to have having a much lower granularity than the WebRTC JavaScript API, that it is like kind of monolithic, to be able to control those objects, to be able to create those test cases. For example, you will be able to have to create each of the simulcast string, get feedback on each of the simulcast string, switch between one and the other, all with a JavaScript API. So you can do this kind of, you can use this functionality to create tests on top. And for example, the basic one would be to create a JavaScript API on the browser that just set the same parameters to configure all that all the simulcast streams, pass that information to the MCU, and the MCU code the JavaScript API to check that you are receiving all the streams that are configured in the browser, to check what is the size and then the image of each of the stream, check the FPS, the frames per second, check if temporal layers are enabled or not, and then if you want, also you could extend that step to extend that test to send back one strip and start switching between these simulcasts to make sure that the browser is able to consume each of the layers that he's producing and with the same frames per second that he's sending. So this is the basic. Then you could start, if we, as we see problems in the browser, we can create a specific test, for example, to test that they comply with sending non-continuous picture IDs, or as the problems arise and are seen in integration, you could create a specific test inside the SVU to make sure that also the error cases are also handled.
Is there some API to check the quality, like the picture quality, image quality?
The image quality, no, because I don't decode it. I can check the image set that it is declared in the BPH stream. I can check the frames per second. I can check the packets, the size of the bandwidth used, the frames per second, this kind of statistics, but I don't decode the stream. That could be one thing more to do, check that what is the perceived quality of the encoding image. But I mean, at this step is not what it is in our near future, at least for us. Sorry? Latency checking. We could do it. I mean, we have runtime tips, but I mean, it's difficult to control when a frame is. If you are going to check end-to-end latency, is kind of difficult because you cannot control exactly when the frame is just checking image by image. I mean, we can control.
Well, you know, there's different kind of testing. Yeah. If you speak about compliance testing, which is the API, there is nothing about quality in the specification. So you could do all the compliance testing without addressing everything you just request for. So what you request for is really important for the user experience. And if you have a product, you absolutely want to test for it. But today, we do not even do the compliance testing. Yeah. So we want to start there, make sure we're compliant. That means there will be interoperability and it's not going to break when I do the call establishment. You only test the quality once the call is established. Yeah. If you cannot establish the call in the first place, well, there's no media and quality to test, right?
Yeah, also.
So this is focused on the browser window, provides the test case for browser window.
So there's two steps. The first step is the W3C compliance testing. In WebRTC 1.0 spec, there is simulcast with an SFU. So we need an SFU to test that. That's goal number one. Mm-hmm. Goal number two, even though it's not mandatory for IETF to test any of their spec, it's very important for interoperability in practice that you do. So the second thing we're going to do is compliance testing against the IETF specs. Mm-hmm. So when we will have compliance testing with both the W3C and the IETF, next step is the quality.
Okay. Yeah, got it.
Yeah, because you could be perfectly compliant with WebRTC, with IETF, completely WebRTC browser, and just send very big square pixels of the image. I mean, and you could be perfectly compliant.
Yes, agreed. Because my team also configuring some WebRTC benchmark, which is focused on the performance and also the quality and latency, like this, and which is maybe also very important for browser. For browser to improve the user experience with WebRTC.
No, this is you're correct. This is important, but you have to do things in order, right? Before you optimize the speed of the car, you make sure that the car can start, right?
Sure,
Right?
sure.
So that's
Totally
where we are
agree,
today. Now, the second thing is, from the standard perspective, the test suite and the test tools should all be open source and with a commitment for the vendor. So you have a fantastic product, you give it away for free, but it's still not open source for everyone, right? So, for example, that would prevent the standard committee from using your tool for testing. So I think that covers pretty much all.
So this project will become a part of W3C.
That's what we're going. The W3C is a big thing. Inside W3C, you have a test platform, test the web forward, right? And the problem is with WebRTC, there are new things that you cannot test with a standalone. And that's one case. How is it going to be integrated or not in the test suite is still not defined. And that's why we're going to have a meeting in November with the working group to see, okay, what do we do about that? So there's no decision made today.
Okay, got it. Thank you.
Do I want to? You mean that mic? No, I'll use this one. All right, thank you everybody for coming this morning. I like the energy in the crowd. This is the second presentation about Kite at this conference. In the first scientific paper, we presented a state-of-the-art of interoperability testing for WebRTC 2 days ago. And that state-of-the-art was made last year in November and presented to the working group at the technical plenary meeting. And the conclusion to that is that we were not testing enough, and we didn't have the right tool to actually test as much as we wanted. So following that, Google was interested enough to actually sponsor a project to develop a tool that would allow for interoperability testing of WebRTC connection and calls between desktop browsers, right? So today I'm going to present you more about that tool. 2 days ago I presented about the past. Now let's talk a little bit about what we're doing now, what we're going to do in the close future, right? So there is a difference between compliance testing and interoperability testing. So compliance testing is to test that a given browser implements the W3C spec according to the specification. And that means that if you write a web page, it should look and behave the same independently of the browser, right? And here you're going to test the thing one browser at a time and check that they look and behave the same. Now with WebRTC, we have a technology in the browser now that allows for browser-to-browser direct communication. And so suddenly, to test that behavior and to test that communication, I need two browsers to communicate with each other. And that's what we call interoperability testing. For compliance testing, there are a lot of tools, and the W3C has its own test suite, Test the Web Forward, or sometimes called WPT. While IETF does not have such mandate and does not require that a test exists before a specification becomes a standard. There are some other consortium like INTF that was represented here this week that try to bridge that gap by doing white paper about best practice, best implementation, and things like that. But that has been maybe a gap in the IETF process so far. So new testing tools are needed there. And those usually are one-off by one individual or company. They're not usually consensus around the tool there. So there's a little bit of work to do. When you speak about testing browser, very, very often, one of the first problematic point was the capacity to interact with the browser in an automated fashion. And so what was originally called Selenium and now merged into a WebDriver standard is actually the solution to that problem. It provides a way to automate any interaction with the browser, any click, any resizing, anything that would otherwise require human interaction with a pointer or a keyboard or whatever, any event can be automated. So each of the browser will provide an implementation of the driver, but each of those drivers will support the same unified protocol, making it easy to write an automated test for a web page whose test would be able to work for any given browser today. There are still a few limitations, but they're very anecdotic. So it made testing the automation of the browser easy. Even better than that, to be able to use Selenium and WebDriver, you need to have all the browser you want to test at disposal, right? And for a lot of the professional websites, you want to test on different mobile devices, you want to test on possibly all devices with all browsers. And that's really difficult to maintain this collection of browsers and operating system. So we saw a lot of services emerging, SourceLab, browser test, TestLink, things like that, that would host those browsers and those operating system for you as a Selenium node, and you would be able just to connect to them and use them without having to configure them, making it even easier to actually test across different devices and different OS. So what about that project, really? The problem with the limitation of Selenium and the limitation of those hosted services like SourceLab is that they most of the time are going to help you test things from the past. They're going to help you test the stable version of the browser and the older version of the browser, but they're not going to help you test the beta or canary, daily, nightly, whatever the name it is, version of the browsers. Which is really, really what you want to do, especially with a specification moving as fast as WebRTC, to be able to catch the bug before they hit your client, before they hit production. If you catch a bug in Canary or Daily, the browser vendor team will be able to put a fix in it right away. If you wait until beta or developer to catch a bug, then unless it's a critical bug, you will have to wait for 1 or 2 releases before your patch goes into the browser, right? Putting your client at risk of hitting that bug for 6 to 12 weeks. If you wait for the stable version, that's even worse. You're gonna need to wait for 2 or 3 releases, and now we're speaking 1.5 months. There were 4 critical bugs in Chrome 58, for example. And you had to wait until Chrome 60 or 61 to see actually the patch to those. So Chrome 58 and Chrome 59 will be doomed for some of the applications. So what we really want to do is to be able to test configuration. So one configuration is a browser and a browser revision. So for example, Chrome 51 on a given operating system and operating system version, Windows 7. And once we have all those configurations we want to test, we want to make a one-to-one call between each of those. So we're going to do pairs of those configurations, right? So for example, browser can be Chrome, Edge, Safari, Firefox. The revision can be for Chrome 61, 60, 59, and for Firefox 55, 54, 53 if you were testing today, right? For people seeing that recording later, those numbers are likely to have changed, and so on and so forth. So last year, we did a very simple evaluation of how many pairs of those there would be. In a very simplified case, you have 500. When we run the most complete run with everything we can find, we reach 3,000 pairs, right? Again, the number of pairs is quadratic to the number of configurations, so every time you had one configuration, your numbers of pairs to test really grows fast. So we came up with this idea of having something that would prevent us from dying by overwork, by trying to manually test all those pairs, right? So we wanted to have a testing engine to whom we could feed a given test, the number of browser, and all the configuration of browser we want to use, and a dashboard, right? So the engine role is just to dispatch the test across all the possible configuration, right? And to run the pairs and so on and so forth and collect the result. Which test is running, it's not aware of. So that means, and it should not be aware of. So if tomorrow you want to run another test on the same configuration, fine, just feed the engine with another test. Same thing, it should not be aware to what is reporting the result to. So you want to get the result on the console, good luck with that, you can do it. You want to report it to a simple web page and to have a visual result and play with the result in a way that is a little bit more interactive, it's also possible. Because the engine does not assume anything about who is going to consume the result, the same way that it does not assume anything about the test. That has a secondary advantage is that you could choose to test your own application when you're on platform. We don't want the engine to know that it's testing Google Cloud or that it's testing Spark or that it's testing the Intel MCU. It could be anything you want, so that anybody could actually reuse that and just make it easier for them to run tests between all the different kind of clients of their system across those configuration, right? So that was really one limiting factor before. There was no existing solution that allowed for testing across two operating systems. So you wanted to test Safari 11 against Edge on Windows 10, you could not do that before. And even if that's an extreme case, I can tell you that there were a lot of bugs between Chrome on Windows and Chrome on Mac, same revision, because it was not tested. If it's not tested, it's broken. So all the design, is very logical coming from the constraint. You would feed a number of browsers, the test, so it's all in Java, so you actually provide the code of the test as a jar file to the command line, and a callback. So the callback is a REST URL to where the engine is eventually going to send the results of the test as a JSON. So of course the test and the dashboard need to know a little bit about each other. They're not completely separated, because the test defines the output and the dashboard needs to consume that output, right? So you cannot have a generic dashboard, otherwise you're going to lose all the specific result of that test. Now, the test is going to provide some output, very specific to the test, but the engine is also providing some output. So if for any reason the engine is failing, for example, you didn't provide him with a Selenium grid that has the configuration you ask for, or if you ask for an impossible configuration, I want Chrome 79, please, then the engine is going to tell you, sorry, I had a problem there, right? So you have a mix of feedback both from the engine and from the test itself. The conductor is going to be the one checking that we have all the configuration at disposal and preparing that array of pairs, right? In that case, we still one-to-one. Later on, I'll show you a multi-party part. The dispatcher is just here to do the multi-threading and do the load balancing against all the tests. A test runner is the one that's going to make sure that multiple instances of browser are actually synchronized. Remember, Selenium can only really speak to one browser at a time. So you need to have something on top that knows that two browsers are actually running at the same time and send synchronize, or sometimes asynchronous, because one will call, the other one will press the receive, right? So you don't have the same comment on both sides of the same test. So that's what the test runner is doing. Test runner can handle an arbitrary number of browsers, which is nice because we started with one-to-one, but really nobody is interested in one-to-one. Everybody wants multi-party with recording and everything. So it was really important from the get-go that the architecture and the design could handle as many browsers as we want. And one very logical extension to that is load testing. Oh, I can run N browser? Okay, let's add one browser every minute and wait for that thing to crash. What is N at the time it crashes, right? Does it crash because the client cannot handle it? Does it crash because the backend cannot handle it? Does it crash because my engine cannot handle it and my Selenium grid is full? Well, there are many reasons, but it's still very interesting to be able to poke the practical boundaries of a system. Again, when all that is done, all the results are sent to a dashboard. And this is where it's interesting. You can use the same engine commit-based. I make a commit to GitHub, it runs that, and send me the result in GitHub, right? That's fine. I'm likely not going to use 3,000 browser configuration for that because that would be too long. But I will take the usual suspect, the one that are really important for me, and that will be my safety net for every single commit. Now, people tend to sleep a little bit less when you're a software engineer, but usually you still sleep a little bit. So you can have a nightly run that can take a little bit longer than a commit. Usually you don't want a commit test to be more than 10, 15 minutes, 20 max. Otherwise, the efficiency of the coder is going down because they're waiting for the result before they do something else. But the nightly run can easily be 4 to 6 hours. And so you're doing a nightly run, and of course, it's not going to be triggered by GitHub, and you don't want the result in GitHub, and so you're going to have a separate dashboard for the nightly run, even though that's the same engine and the same test running. The only difference will be the number of configuration and then where you send. Now let's say, even better, you have a full automated continuous integration pipeline where every time you push a commit, there is a very complex Jenkins pipelines that go through a lot of things, including that. And then you could instead of sending the result to a dashboard, send the result to something else in your Jenkins dashboard to validate that things went well enough to go to the next step. So we wanted all those use cases to be compatible with the design we had, and that's why we separate completely the dashboard from the rest of the thing. This is how it looks like. Quite ugly, but it works. We engineers, remember. So that's the simple dashboard. This thing the desktop browser part of this project will be completely open source by Google next week on 9th of October. What you're seeing here is provided, right? We wanted to provide a full environment for people to really start playing with it and not looking at JSON, at 10,000 lines of JSON on the console. That's not appealing. So we did a small dashboard as a web page. You have each of the run like that, with different kind of success or failure number, and the list of all the browsers that were actually tested during this run. If you click on one of those, you get more details about the run. You got the date, you got the time it took to run it. We wanted to be able not only to check if it was working or not, but how long the test would take to catch any possible performance regression, right? So it doesn't fail, but then suddenly it takes 10 times more to run. You do have a problem, so you need to expose the time as well. Originally, we went for a square design here that was very, very influenced by the work that the Skyway entity team had done on the NAT travel zone. And for one-to-one call, it makes a lot of sense to have a grid with the browser configuration on the x-axis and on the y-axis. Now, when you have 3 browsers, and it's becoming slightly more interesting, so we moved to a circular representation, which has the advantage of actually accommodating any number of browsers. So in that case, you have pairs, right? So you have the list view on the right hand with the caller and the callee. Remember, it's not symmetric. Sometimes you call one way and it works, and sometimes you call the other way with the 2 same configuration and it doesn't. Plan A, Plan B, unified plan, anybody? And you have the circular view on the left hand. I'm going to show you a little demo after. I'm going to interact with the mouse. You can see how it works. We wanted the result to be understandable by people that can do PowerPoint and choose between right click and left click, upper management. And so that's what we came up with. So that was the open source part of things. All the desktop browsers are there. It's fully complete. We've been using it and finding bugs and reporting them to the Apple team and the Mozilla team already. And we also have some commercial models through Cosmo for things that were not of interest to Google at that stage, but we think are going to be to interest to maybe smaller company or people that focus a little bit less on the desktop browser itself, but on other kind of clients. First, you want to do multi-party. So we did a little test with Jitsi. So you can see that my onion here has one more layer. So the internal blue, shade of blue layers are now up to 3, right? And then the external layer, which is the result, is still only 1. We, of course, choose only the configuration that worked. So that's why it's all green and everything. The idea was just to show that you can actually do 3 people, 4 people, as many people as you want, and the engine can support that without any modification. The only thing you need to modify, of course, is the test and the dashboard, right? And so it's a very small modification to actually support a different kind of platform altogether. So we took Jitsi Meet, the hosted version, and a different number of browsers and so on. So that was, I think, that illustrates our point. You know, you can see the list of browsers now. You have triplets, right? You have tuples of 3 configurations. Another thing that is really, really interesting, and I think if you look at the conference, those 2 or 3 weeks, it keep coming back. It's like, okay, browsers are nice, but more and more people want to go beyond the browser. So they want to have the advantage of the browser, but again, getting close to native, they will go for something like Electron or Chrome embedded frame. The first one is getting more popular than the second one. The second one is a bit older and was the only alternative before the Electron project, but it's basically the same. You're going to use the Chrome code, embed it in your application to be able to write your application as a HTML5 web page. We're also very interested in mobile. I was working at Citrix before as a chief architect for GoToMeeting, GoToWebinar, all those products. I can tell you mobile is key. This is more than 50% of our user, and it is a hell of a lot more than 50% of our revenue, right? And that's true for all the big company. You take Cisco, you take Ericsson, everybody that has a product like that, and will tell you the mobile is very important and it's much more difficult to test. So there are some frameworks today that allows to have a Selenium compatible layer for mobile application. And so that means it's directly compatible with our project. So we have models, commercial models that handle that for you. So finally, if you saw the presentation from Irene the other day and a few other, most of the enterprise clients are still on Windows 7, which means they don't have Edge, which means they're still using Internet Explorer. And in Korea, that's 21% still of the guys. So if you saw the drawing from Mr. Lee last night, Chrome is there, but Internet Explorer is still there, and you really need to take that into account. So we need to, we're developing yet another Internet Explorer plugin with the difference that it's going to be open source, it's going to be free, and it's going to be part of the testing infrastructure. So you actually will have that Internet Explorer plugin tested against all the desktop browser and everything that exists on a daily basis. Finally, what's interesting more and more nowadays is IoT. And here again, it's very diverse. So for all the people that came to the tutorial the day before the conference on Qt and LibWebRTC, thank you. And that's an example of what you can do to unify a little bit all those applications on IoT. So here, Janus is a very good SFU, since it's written in C and it's very lean, and it's been used by many people actually on IoT. Again, the entity team Skyway is using Janus in their IoT SDK. So we have an environment that is completely C++, that is compatible with most of the IoT chips, and that we can test directly against the other browsers as well. Because again, doing a first proof of concept is nice. Testing it and make it, you can make it strong. Now we propose to make it army strong. Unfortunately, setting up a Selenium grid, especially for different kind of browsers, is still difficult, right? So we have developed a grid manager where basically you provide credential for AWS, you provide credential for Source Lab if you have any or any of these hosted services, and it's going to deploy and maintain the grid for you. A part can be static, a part, a baseline, a part can be on demand. It's really transparent, and again, everything is done through a web page, so you need minimum coding skill to be able to do that. Some people want to be able to have a virtual machine on demand. That's what people do with GitHub and Travis today, nowadays, right? But in some very specific case that require manual setting to be able to have WebRTC testing capacity, and here I'm thinking about Safari Technical Preview or Safari 11, where unfortunately is not fully automatable. You might want to set up a specific configuration on one machine that you keep around. And then your grid manager will have a collection of hosted machine in the cloud, local machine. You can add your local computer. Let's say you're hacking like Sergio. I want to put double encryption in Chrome. And it's taking me 2 days to compile Chrome. Joy. So I'm not going to do that all the time. I'm going to keep it on my local machine, and I'm just going to tell the grid manager that my local machine is actually a node, right? And so the modified browsers that I have, maybe because I have an extension for screen sharing, maybe because I have a plugin, maybe because I hack in the code of Chrome, will be part of the grid and will be tested against everything else. So that's one part, I think, that is very flexible and very interesting and helps covering most of the use case there is out there. That's pretty much it for the product presentation. Thank you, everybody, for coming at such an early time on the last day of the conference. And if there is any question, now is the right time. I see a pensive face over there. I feel like a question is coming. Neil?
If we were to run these tests against, say, one of these IoT devices, we would set one of those up as like a node similar to, as you just described, like a local desktop environment.
Correct. From the engine point of view, you're just an additional node. They don't need to know it's IoT or not.
Okay.
So in a multi-party test run, right? So do you consider timing issues as well?
We collect different kind of timing. But for example, in Source Lab, it can take forever for an instance to set up. So what you're really interested in the time the test run, between the time it's actually really launched, and the time it runs, not between the time you send the request for the test to be run and the time you get the result. So eventually we separate all kinds of errors and all kinds of timing to make sure that what we measure when the test is run on Source Lab is comparable to what we measure when it's run locally on a virtual machine.
Okay. So do you have like user profiles as well? Like when you're running a test, you can basically add a user behavior when you're running an application as well.
Well, it's fully automated, so there is no real user. I'm not sure I understand your question.
So you can basically model a user behavior saying that in an application you have multiple buttons, and you can apply a model saying the Markov chain model, and then the user is clicking one button and he's clicking another button.
Selenium allows you to do that, but I'm sorry to report that with WebRTC interoperability, we are basement zero, right? We are ground zero. Means what we need to test today is can the call succeed, right? And now we know that the engine is stable and so on. We're working with Google to implement more complete tests, all the statistics and so on and so on. But before we do that, there is a lot of things you want to test before you go into behavioral testing, if that's the right pronunciation for the word. So we're not there yet.
Okay, thanks.
So I promised a demo, so here it's coming. It's a little bit better than the original fully black background, but it's still an engineer website, and I'm sorry about that. So you have different kind of run that run on different days. You also have the overview option, which allows you to, now that's a beta version of Safari, sorry about that, that allows you to basically view everything that is in the database, all the results you ever had for the entire life of that thing. It can grow pretty big. Here we did a very simple instance for this, because as soon as people see the link on top of it, they're going to DOS or server. But here we just did a small run with 64 configuration. This is the overview and this is the detail. Let me open in a non-beta browser. Right, so you see the list on the right-hand side. If you click on it, you have the log. But of course, when it's successful, the log is okay, which doesn't give you a lot of information. The log becomes interesting when you have failure case. Now, I told you, you can actually filter and say, I only want to see the successful one, or not see the successful one, so in which case that's 100%. But you can filter by type, or remove the blue errors that are the Selenium error. Because the Selenium error, I suppose that if I retry, it's going to be okay. It's not a test. The test didn't fail. Selenium failed to give me the virtual machine. So the interpretation of that failure is quite different. We're thinking about actually retrying several times the Selenium failure. SOSLab has been slightly unpredictable for us so far. But now you can say, okay, I'd like to see this browser first, calling that browser. Boom. The results are all possible. So you can interact with the menu on the left, just to have some fun. Or you can interact directly with the widget in the middle. Say, okay, I just want to see this browser first, calling this one, and then that one. All right, it's green. Tell me, okay, you don't have to zoom that much to go in there. But imagine you have, I don't know, 7 layers, or 10, 15 people, 1,000 people in the call. I don't think you're going to interact with the central widget. I think you're going to go for the list, right? That's what people would do. So we spend a bit of time making it a little bit easier to use and to visualize the result. All right, 10:30.
The user needed to create a signaling server for some SDP exchange for testing?
Yes. So you need a complete application that means with a signaling server. So in the first example we gave you, we used AppRTC. For this example, we used the hosted Jitsi Meet. So Jitsi Meet Me.
So the user can change different signaling server by the requirement?
By the test. You write the test call any URL, anything. So because you control the test, you control also what you test against. The engine is just handling the distribution of the test and the synchronization across the configurations.
Thank you.
Well, thank you again, everyone, and have a great day.
IIT Conference and Expo. It's my pleasure to introduce Bithika Kargaria from the MEF, and she'll tell you a bit more about that as she gives her talk today. So thank you all, and thank you, Bithika.
Thank you, and thank you for sticking around until the very end, because I believe I'm closing out the conference. But I think it was fantastic. I got here yesterday, missed the hackathon, but really got to learn some very interesting stuff in the real-time space. Because where I work in the MEF and previously with the ONF and Extreme Networks and Cisco, a lot is about networks and services. But here, the world of application meets the world of infrastructure, and I think that's where all the magic happens. So my name is Bithika Kargaria. I am a technical program manager at the MEF. I recently started there. Prior to that, I was with Extreme Networks as a principal engineer. But I worked a lot on SDN-related solutions with customers across the globe in different countries. And then before that, with the Open Networking Foundation. So I have quite a bit of experience, of course, in software development, but also in product management and in open source communities. So I'm here today to talk about applications and network automation. As I talked about, I feel this is where all the magic happens. The boon and bane of existence of infrastructure is to be able to do better with applications, and that's where application-driven network automation comes to the forefront. So, I'd be very surprised if there is one person in the room who has not heard this term, digital economy, mentioned over and over again. And I think it's one of those terminologies that's beginning to get used in all kinds of ways. And it has some interesting flavors, especially from the programmable networks and services perspective. But really, what it is an economy that's based on computing technologies or digital technologies that involve computing, storage, network. And a few years back, I was actually giving a talk at one of the other conferences, and I came across this very interesting, an example of how the digital economy is evolving. So, any NASCAR fans in the audience? Nobody? So I read about this really interesting example where Daytona 500, the racetrack, had an oil spill. It's a crash, essentially, on the tracks. That was back in 2012. And one of the drivers, I think his name was Brad Keselowski. I don't really follow NASCAR, but I did live very close to Charlotte in North Carolina, so I did go to some of the tracks there. Felt a little bit out of place, but it was still a good experience. So the driver he took a picture of the track with the oil spill and he tweeted, and immediately his fans jumped on his Twitter feed and they were talking about, "Hey Brad, are you tweeting and driving?" That sort of thing. And then Tide, the thing that you use to clean your laundry at home, right? They send their crew out to the racetracks to clean it up when there's an oil spill. So they saw that there's an opportunity to sort of get into a timely conversation that engages their brand in an interesting way with their fans, with the fans. So they took a picture of the racetrack with the Tide crew being on the track, and they posted that picture from their perspective. And they said, let's get some captions, and the best caption wins. But I think that's such a great example of this hyper-connected community where devices, people, content, it's connected to each other 24/7, right? And we want everything on demand. We want everything now. I take a picture. I need to upload it now. I need to share it on WhatsApp now. It's all about now. And a lot of the infrastructure pieces underneath is, for this kind of real-time responses, it really needs to be machine automation. And I think parts of that is there, and parts of that is beginning to be there because of these type of drivers. And the other piece is cloud, right? It's really becoming a utility. A lot of the applications are moving to the cloud. So really the question that we are asking at the MEF, the Metro Ethernet Forum, which I guess I didn't get a chance to introduce, but we're a standards organization. We also have an open source arm, so we do software development as well as open source. as well as standards. But those are the type of questions that we're trying to answer. There's to, this digital economy is coming up. What are the underpinnings that we need in the infrastructure to be able to support as the technology matures? When we really revisit that, we see that three key attributes come in, right? The underlying infrastructure, it needs to be very agile. So elasticity, we talk about that all the time. It needs to be on demand. We need assurance, performance assurance, security assurance, end-to-end. And automation orchestration. Today, creating connectivity services between one endpoint and the other, it's very ad hoc. It involves phone calls and raising tickets. It takes months. How do we bring it down to weeks and days and maybe hours? And we'll need that for that hyper-connected, on-demand requirements that's being placed in this infrastructure. So if we really look at, given what we need, where are we? If you're sitting in this room, you're probably affiliated with some kind of an enterprise, a small, a big one, some kind of an enterprise organization. And all CIOs are coming in and saying, look, we need to outsource percentage of our applications into the cloud, and we'll have a journey to get there, but everyone is in this cloud transformation journey. So on the one endpoint, you have your applications. So in this scenario, on the cloud, we use the examples of real-time applications specifically for this community. Beyond RTM, also applications like AR, VR, applications like video surveillance. So all of these applications have really stringent requirements in terms of performance guarantees. And when we start outsourcing or moving some of these into the cloud, what happens to the enterprise on the other end, or the other endpoints, residential or your mobile endpoints? So previously, when enterprises had complete control over their infrastructure, they set up their own infrastructure to run their applications. They knew if something was wrong with the application not behaving well, they knew exactly what was going on. They could troubleshoot, at least to some extent. But in this case, the minute the packet leaves the enterprise network and goes over those clouds of disconnected service provider domains, it's a black hole. Nobody knows, what happens to the packet, why are they not getting good performance, or even if they're actually using all of what they're paying in terms of connectivity. Many times it's over provision. So there is lack of SLA guarantees. You kind of put it out there and you hope and you pray that it works. It works a lot of times, but for real-time applications, there are, I think, some unique challenges. There's lack of visibility, as we talked about. And then just from the perspective of setting things up, it's extremely complex because there's just too many moving parts, not only in the vertical stack, but also in the horizontal stack going from the left to the right. So is it a good fit to deliver on some of the hyper-connected, digital economy attributes that we talked about earlier, and what do we really need? So that's where, that's most of the work of the MEF. This is where we focus on. And so, that's essentially what we're saying here is that how do we really bring these attributes of agility, assurance, and orchestration into that connectivity across multiple service provider networks that may include wide variety of technologies, from SDN to NFV to the traditional infrastructure, including SD-WAN. So we really try to use APIs to orchestrate across those heterogeneous technology domains. So here, I think really the name of the game is APIs. So if you look at the paradigm of software-defined networking, came in and said that it was Nick McEwen's presentation, the professor from Stanford who collaborated with a few other people to come up with this, but they say that what happened in the 80s with microprocessors, we are trying to recreate that with networking, where we're trying to break up the stack, and we have APIs from the switching chipset to the operating system to the applications, and all open and standards-based APIs in between. So each layer now has independent control over the layers underneath to be able to do what the end users need, and they don't need to depend on the roadmap of their vendors. So I think it's a very similar model here as well. It's really, if you go back to this slide here, if you double click on a service provider network, it would consist of many layers of the networking of their infrastructure stack. And now it's opening up because of SDN and FV. And with the APIs that they expose, those APIs can be used in collaboration with new type of applications to do this sort of more application-driven programmable networks. Today, that awareness between the application and the network doesn't really exist. I mean, there are some roundabout ways of trying to figure that out, but with encryption, and Gert is sitting here, he can tell you a little bit more about that, their experience in Microsoft IT. There are some roundabout ways, but there really isn't direct ways for an application to do or to rely on machine-to-machine automation to set up that entire connectivity path with the right performance attributes and security attributes end-to-end, and get the type of agility insurance that you need for the digital economy. So here it shows that with those APIs, you can pretty much, you should be able to, our goal is to do that orchestration of services in the networking stack, all the way from L1 to L7, do it all automated and orchestrated, and why not, right? I mean, with SDN, with NFV, we have some of these capabilities today, and I think what we're missing is that application fees. And that's where those application APIs come in. Within the MEF, we call it the intent APIs. And these, it's a working group that started out in the Open Networking Foundation. We still call it the NBI, Northbound Interfaces. But it's someone presented in one of the sessions yesterday. It's sort of a way for applications to be able to tell the network what they need, and the network figures out how to provision that. So it's sort of the high-level goals are specified in those intent APIs, and the execution of those goals in terms of the performance and the SLA and all that is taken care of by the layers down below in the level of a service orchestrator or an SDN controller or a lifecycle services orchestration platform that I'll talk about, the work being done in the MEF. So just from, I guess how, and a lot of this work is in the progress, but what would the functional blocks look like for such an architecture? I think that's what really it's trying to show here for this application-driven programmability. So at the very bottom, you will see your programmable network elements. So that's where you will have your physical network elements, your virtual network elements, your PNF, VNFs, as well as your legacy equipment. The layer above that is the controlling entity, typically your SDN controller or your service orchestrator, or sort of a inter-domain orchestrator like a LSO that the MEF is working on. And then the layer above that is where your applications are being hosted. So if it's a cloud setup, it's probably running some kind of a running in the context of microservices with many points of presence between the cloud all the way up to the edge, regardless of whether it's a data center, your regional POPs or your edge POPs. But that's the application is sort of now loosely coupled and possibly running in those in any of those regions and collaborating together to deliver the application services that it's designed to do. But requirements coming from that application through intent APIs, through application APIs, things like elasticity, things like delays, being able to specify delays, packet jitters, and things like that, which then goes into the program, the programmable network piece, where those requirements come into an LSO, into an SDN controller, into an FV service orchestrator, and then they get programmed using SBI, or what we call southbound interfaces, protocols like OpenFlow, maybe NetConf, or any of the other legacy protocols that you can think of could be used in that layer to program the data plane underneath, not just, I guess, switches, but also services. So it's probably a 30,000, 40,000 feet view of it, and we are still, the intent working group is something that's been recently, in fact, instantiated within the MEF, and this comes from, so the IMTC recently entered into a resource transfer agreement with the MEF. So as part of that, some of the RTM, especially RTM SDN work and a few other areas, they'll actually be, continue the work in the context of the MEF, and that's where SDN APIs for RTM, real-time media applications, would be a driver for some of this programmability. So this is an example of real-time media SDN APIs, and the source is Skype for Business. It's, if I remember, it's actually one of the poster child of SDN applications. And Pascal's been involved in that for people who know him through IMTC. But he did some phenomenal work in terms of working with many vendors to define how would SDN APIs look like for a collaboration application like Skype for Business. And they said that, okay, let's define some session events, and let's define some quality events, and let's make those APIs open so that an SDN controller, for example, could subscribe to those APIs. And you know, let's say there's a session event with a start event, and that gives you information like what are the IP endpoints. And that information then goes down through APIs into an SDN controller that could then pin down the media path for the media stream to flow through. The same thing you can do with quality events too. So by the way, in this case, in the session event case, what happens is that there may be multiple possibilities of getting from one IP endpoint to the other, but figuring out what is the most optimal path based on whatever else is going on in your network, that is determined by the networking piece, because it has complete visibility in terms of the administrative domain that it's managing, and it gets the requirements from the application. So you see the beginnings of intent and application-driven programmability with this work. The same thing with quality events. If there are delays, so those can be specified also through the quality events down into the network that could then either do proactive reprogramming or reactive reprogramming to be able to find alternate paths to be able to provision these or deal with quality events. So some of this is actually in deployment today, especially on-premise Skype for Business. And if I remember, NEC has an SDN controller called Programmable Flow Controller. So they worked with integrating Skype for Business as a complete SDN application over programmable networks. So a lot of this is in deployment today. Skype for Business does not have the cloud APIs, but I think that's in the roadmap, so it's going to get there. And then that's where all this inter-service provider work that I showed to you becomes relevant. So we talked about intent, and really I think we're in the beginning stages of it. This is one of the topics that's really some people feel very passionately about. One of the person that I work with, David Lenro, he's not here, but I think he's going to be very intimately involved with the applications working group also in the MEF. So the idea here again is that I as an application express my intent in terms of what I want from the network, and the network figures out how to execute that. So we really need to provide vendor agnostic APIs that are in the application speak, so to speak, not in the network speak, not in terms of bandwidth, and not in terms of the language of the network, but in terms of the language of the application. How can it specify its needs into the network? So this is a slightly older chart from the work that we did in the Open Networking Foundation, which essentially shows the beginnings of this construct. There is no guarantees that it's going to continue to look like this. And at the time, we were not looking at inter-service provider orchestration. So this shows a lot of the intent constructs within the context of an SDN controller. But I think now, the more I think about it, I think the better place for this is really in the LSO, in the orchestration layer, rather than the SDN controller layer. But you see here are two databases. On the left is your intent repository. So that's where you're essentially going to specify your objects and your object groups, as well as modifiers, where you can where you would be able to use sort of a policy language to specify what the intent is for the application. And then on the right hand is the mapping, where the intent at the end of the day has to be mapped to the underlying network. For it to do that, really you would need to know what is the status of the network right now in terms of what traffic is running and what paths are available and all that. So the intent has to be mapped into its execution context or its local context. So that's what happens in a mapping repository. And and then there is the intent engine in between that does the so it's sort of a realignment in a sense of what was the desired state based on the intent that the application expressed, and what is the actual state in terms of what the network was able to deliver. So it does some sort of realignment, readjustments based on that. And also there could be policy conflicts at times, because there could be many applications specifying intents into the same network, and those resolutions also happen in the intent engine. None of the code exists for this, by the way. This is really in the chart. And I think that the Open Daylight NIC project, the Network Intent Composition, and I also believe that the Group-Based Policy project have similar constructs and philosophies for this that has more code than what we have here. But in the East-West, there are sync APIs with the goal that we may have separate administrative domains where we have SDN controllers running and programming the network. We don't want to replicate the network state across all of these domains, but really keep local state, but keep them in sync. So those are the sync APIs East-West. And then the North-South APIs are essentially like a GUI. You can think of it that way, where someone could come in, an administrator could come in and specify intent through the client, intent client, or through the mapping client. So if this work interests you, definitely please talk to me, because this is the community we need to work with as we define some of these elements. And also, I believe in Open Daylight, it's a fantastic community that if you wanted to get involved, get your hands dirty with some of the work that they have, especially with GBP and with NIC. I think that's also a great starting point. But we need the applications community, to do some of this work. It moves the abstraction from the network to the application, and so this would be a great place for that. So we talked about the on-prem, implementation of Skype for Business, and we saw some of the APIs in that space. But now what happens when you move this, as it is, I think to really do these deployments on-prem, they are quite complex. They have many pieces into it, and troubleshooting can be quite complex because a lot of these problems are intermittent and they're heavily dependent on the network. So if you don't see an exact snapshot of what's happening when the problem happened, then it's hard for you to recreate and all of that. But now you take that same UC application, a real-time media application, move it to the cloud. You've just increased your complexity by tenfold, if not more. So that's where some of the on-prem work, as it moves to the cloud, would be addressed by a framework like Lifecycle Services Orchestration, and how could we do assurance agility orchestration with that. And this is the work that I'm involved with in the MEF. So here you see a self-portal where a consumer, could be an enterprise, could be another service provider, could come in, and with a few clicks of a button, he could specify what type of connectivity service he would like to buy, and between which endpoints. And with a click of a button, he sets it. All of the, the quote, the setting up of the pinning of the connectivity, the figuring out of what services need to be there as part of this connectivity service, all of that is automatically taken care of within a service provider domain and across service provider domains using this framework. And really the magic is with where that LSO piece sits in, Lifecycle Services Orchestration. So it does the orchestration over across or inter-carrier, as you see in the clouds here. And within a carrier, it helps do the orchestration and automation across multiple technology domains. That's where SDN, NFV, SD-WAN, optical, 5G, all of those technologies come into the picture. It seems extremely complex when you really think about it. And a lot of people have this thing saying, okay, it's too big of a goal to be able to accomplish. And I think it's true, and that's what makes it exciting. But if you really look at it, what this does is puts control literally back into the hands of the end user, the consumer who's coming in and saying, click, 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 this is what I want. Just set it up for me and tell me how I'm using it, because there's visibility is a big piece of it as well. And it's elastic service. I mean, again, I think AT&T has network on demand, capabilities. I think it's rolled out in some limited capability, but this wants to take it across multiple, service provider vendor domains. So it's really bringing the cloud consumption model into the network, where you pay for what you use, you scale up when you need to, and you have a lot of control in terms of when you're asking for something and how you're asking it. So now with this, think about replacing that self-service portal from the point of view of one service provider buying service from another service provider, and replace that with an application actually using this portal in an automated fashion using the intent APIs. So that's where you will see that the application should be able to specify its intent requirements across multiple networks, and each network would take in those requirements, program that using the LSO and the technologies underneath, and it will just provide end-to-end quality of experience, end-to-end visibility and diagnostics. At least that's where we want to get to. So in terms of the API stack, the name of the game is really, it's open APIs, standards APIs, APIs that the community comes together to determine and to build. So you'd see sort of a SaaS application using application intent APIs into the orchestration layer. And the orchestration layer is where it's going to deal both with the networking piece, the connectivity services, as well as the layer 4 to 7 services. So that's where the orchestration would sort of go into the software programmable networks, again, using orchestration intent APIs. And then from the software programmable networks, using southbound interfaces, protocols, you name it, BGP, OpenFlow, NetConf, any of those RCLIs for that matter, to program your physical and your network, virtual network elements underneath. So this is kind of how the API stack will probably end up looking like. And in the MEF, we are, at least right now, working in each of these domains in terms of defining how those interfaces would look like, what would be the APIs in those interfaces, and also how do we consume them in real-world use cases. So we're really looking at all of that. So current model of that orchestration piece that I talked about, it has the SDN controller that's really responsible for the network piece, and then it has the NFV orchestrator that's responsible for the services piece. So obviously this one is working with physical network functions, and this one is working with virtual network functions. Well, I mean, this could also work with virtual switches. And then the layer above that is where you have the orchestration piece. This orchestration exposes API northbound, like the intent APIs for applications to speak to, and on the south it talks, another standard set of APIs to or your controller or to your NFV orchestrator. But I think the point really here is that these work together to provide the connectivity services. But with the help of orchestration, with the help of this orchestration, you actually get capabilities on top of those services, like fulfillment, like assurance, like performance, like analytics. And a lot of the beginnings of this work already exist within the MEF. So we have a good foundation to start from. So what is the proposed model, especially with this IMTC, the real-time media work coming in, is that we have a lot of these pieces already, but we have those application intent APIs into real-time media applications. So that's where, Carol, as I was talking to you earlier, your students, I think this is a great opportunity for them to get involved and see, how should intent definitions look like, and how do they take those telemetry data and look at some analytics and insights from there. I think that'll be a great opportunity. In fact, for any of the folks in the audience to contribute, that's where the application and the network come together. So in terms of application programming models, so this is obviously, this is sort of the ideal model, the ideal mode of operation where an application is directly communicating requirements through intent APIs into the orchestration layer, and the orchestration is then programming the network underneath in order to provide the right type of quality of experience. And then they also expose telemetry data, which goes back into the application to say that, well, this is what I asked for, this was my desired state, and this is the actual state. So do I need to reprogram? Do I need to request reprogramming so I get the right kind of experience? So this feedback loop, you'll see that quite a bit in a lot of the work that we do. So north from the application to the network, and south from the network back to the application. So this is where you would see applications like Skype for Business that have SDN APIs exposed today. But a lot of the applications are legacy applications that people probably wouldn't go into the business of rewriting them in order to speak intent. There might be some startups who may do this in this space, but not a very scalable business model. So for those, how do we bring them into the new models? So one is sort of obviously DPI. That's what SD-WAN does a lot today, and the other one is with introducing synthetic traffic. So DPI, and both the DPI as well as the synthetic traffic, they act as a proxy for the application, and they obviously try to determine what is it that the application is getting by either doing the packet inspection, or by introducing synthetic traffic in the path of the application to make a second-degree assessment in terms of the quality of the network that the application is experiencing. But even with these models, you'll sort of have the proxy speak intent. That's at least our goal within the MEF. And then you'd see the same feedback loop here as well, except that here you get the telemetry data from the DPI or from the synthetic data, not directly from the application. But with the IMTC work, we are sort of starting here because some of these UC applications are actually open source. So with developer communities coming in, we could experiment with this first before we get into some of these other models. So this is the analytics piece. So we've been talking so far about intent. So from the north application to the controller, but what happens south from the controller back to the application? So this piece, the LSO or the orchestration piece, is what we're developing within the MEF. And there is open source code contribution by Cisco of a project called Panda. And in fact, there's Charles in the room who knows a lot about that. So if you want to know more, you should talk to him. But I believe that it has two pieces. So it has a data lake that collects the telemetry data from the network, from the application, and from the service orchestration. And you have that big data there sitting in. And then now you run your analytics application on that data to try to figure out the state of the network, the real-time state of the network. So there could be some real-time programmability being driven into the network in terms of the desired state of the network that the application had requested. And these could be event-driven, and obviously the network, the application, or the orchestration could feed events into the analytics, or it could also be more sort of a polling mode where it runs every so often. I mean, I'm not very familiar with this space, but I should assume that when you're trying to mine intelligence from a huge amount of data in real time, that itself, would be processing heavy, and there will be optimizations that would need to do there in terms of how frequently you run your analytics on the data. How do you actually run it to maybe in a distributed fashion to be able to, generate real-time, analytics? And clearly, people like Facebook or Google has solved some of these problems with the advertisements that very quickly appear in your Facebook feed because you searched on something on Google. It's quite scary sometimes, but that's how things work. These are data, but we have no control over how to use it. So when I was at the ONF, actually, we were looking at, my directives at that time from my boss was that how can we accelerate the adoption of SDN, especially in the enterprise? Because service providers are doing a lot of things with that, but enterprises are trying to figure out kind of how to get into it. And we said, well, let's look at some use cases. And enterprise UC is one of the, most enterprises have some kind of collaboration that they use. And we looked into IMTC, the requirements were very well defined, both for automated QoS provisioning, AQoS, and automated diagnostic provisioning. Some really nice requirements, specifications being written there. So we really got the use case definitions from there. And part of it was implemented as part of the ONF work, but we never got to completing it. Hopefully, with the work transitioning over to the MEF, we'd be able to flesh out a lot of this in the context of a broader scope of orchestration and not just SDN controllers. But here, you'd see that in order to provide this type of automated QoE, you'd need to provide things like dynamic QoS marking or dynamic traffic engineering policy. And these are, by the way, defined in a lot of details in those specifications if you want to figure out what these are and why I would need them to have this automatic or autonomic QoE end-to-end. So here is where the UC application will be sitting in and specifying requirements through probably a QoE API. And these are the services within the orchestrator that would essentially or determine how those APIs or how those requirements should be translated into the local context of the network that the application's running on or using. The same thing with the automated diagnostics use case. And here you'd see things like session monitoring or data collection, both from the application and the network, and analytics. And again, some of this is a beautiful merger, I should say, between the IMTC and the MEF, because if you look at the analytics piece within the orchestration, it already exists. So now we need to figure out a way to collect that data that's specific to these RTM applications and run the same analytics on that data. So it's just nice to have some of those foundational pieces in there. So now finally applying that to cloud applications, or what happens when you move RTM into the cloud, you can kind of envision that there is this cloud that is your enterprise endpoint that's using your RTM service. And then you have your service provider clouds in between. And each of them has an orchestration block, right? That orchestration block is essentially programming either SDN controllers or NFV orchestrators underneath in order to program the network. But this LSO controller, it really implements the automated diagnostic service as well as AQS, or automatic quality of experience services that were defined in IMTC. And these would have the open APIs all the way up to the cloud, the RTM applications that's sitting in the cloud somewhere. And so the idea is that the RTM application should be able to specify using the API should be able to specify requirements through multiple separate administrative domains, and each one programs itself to provide and collaborates with each other to program itself the end-to-end quality of experience and end-to-end diagnostics and visibility. And I think it's not exactly an easy thing to work with, but again, with some of the technology pieces already existing within the MEF, it should be at least an interesting onboarding of the IMTC work into the MEF. So what I want to do next is maybe take a quick look at some of the real world, what is really the industry doing in this space. And this is, in fact, one of my favorite, charts that Dave Ward, the CTO at Cisco, he presented at Open Networking Summit a few years back. This is also interesting for me because before I came into the world of networking, I was actually in the world of servers, and I wrote algorithms to optimize the memory consumption for data center servers because that was a big concern then. I know that it's still a big concern with the power consumption and data centers getting bigger and bigger. But the idea there was when you write algorithms, you want to automate them and you want the machine to be involved in the decision making, not the manual processes. So we looked at this. At the time, IBM had defined this terminology called autonomic computing that was very similar to the way the human autonomic nervous system works and how it reacts to different events that the body gets subjected to. Things like your blood glucose concentration going up. What happens, when that happens? How does the body regulate itself in response to that, without anyone else need to coming in and tune different aspects in order to deal with that situation? So it's sort of the same idea of autonomic computing, which it's obviously my interpretation of it, but applied to the world of networking is what he's describing here as reactive networking, is that you kind of see the application or the PaaS layer here specifying work intent, API, specifying intents in terms of its requirements into a workflow, which gets programmed by the orchestration layer that manages your services and your network. So it's really programming the network. And then the network, in turn, is exposing its telemetry data as well as the events for analytics to run on it and to feed it back to applications saying, this is what you asked, this is what you're getting, do we need changes? So there's sort of this really nice handshaking or a feedback loop going on between the application and the network. And in my opinion, in today's world, it really just doesn't. We're not there at that awareness between the application and the network. It's we're using DPI, we're using some other techniques like that, but it's very indirect. I think this makes it, it's a very empowering model perspective. And again, I'm not very familiar with the Cisco portfolio, but I do believe that there are, perhaps Charles can answer that, but that there are some controller offerings that actually implement some of this architecture and these ideas into products, which means they're in deployment today. The other example is the Google's Project Espresso. So Google has about 200 points of presence throughout the globe. And they are, they're a media company at the end of the day, or a marketing company. And their business is really about every person in the globe being on the internet. Everyone needs to have connectivity. And hopefully they need to have really good connectivity. It's all about, accumulating all that data in terms of user behavior on the web and trying to push advertisement based on that, in addition to other things. But it's really about that. How good is the connectivity, or how much of a good connectivity can I as a company push all the way to the end user as far out as I can go. So that happens to be the point of presence, or the IXPs where Google peers with other service provider networks in order to take their traffic forward. So in those points of presence, what they're doing is that they're saying, I'm going to get rid of these expensive routers that speak BGP, and I'm going to do write my own networking stack. So they're taking some white label switches. They're writing a BGP stack, which, from what I read, it's completely compliant. But nonetheless, it's something that they rewrote in order to optimize things for them. And then they have a local controller that's essentially managing that infrastructure in the context of that POP. The job of the local controller is to really look at or talk to the server, the host that's running the applications. And so it looks at every single packet that comes out of the host in terms of the applications that it's running, and it stamps that, or it labels that. And that label is used by the switching fabric here. The switching fabric is actually pretty dumb in the sense that it looks at the label and it says, oh, if it's label A, I need to peer or go out on a certain port. If it's label B, I need to go out on a certain port. So that determines the peering decision. But the point here is that it has a feedback loop going on in real time, because there is a global controller that's sitting over here that's collecting data from all of the hosts in all of the 200 points of presence that they have. That's essentially telling the global controller, so this is your telemetry data. It's telling the global controller, well, the last time I decided to peer with a network A over here using a certain label, and I got this type of performance. I need to make some changes there because it was not the type of performance I was expecting. So this time I'm going to do peering a little differently. So the global controller essentially runs that analytics to figure out which local controllers need to be communicated with the right labels and make those changes so we get a better performance the next time. And they're doing this obviously at scale and at probably 10 times less the cost as opposed to using your regular BGP routers. So the part that's really interesting from here is that the application to the network and network back to the application, that feedback loop, you see that also in the works here. It's obviously not intent-based or standards-based APIs, but the same philosophy is being adopted here. And finally, of course, we talked about Microsoft Skype for Business, many deployments, instances of that running, and Skype for Business is now moving to the cloud, so that means the cloud SDN APIs are going to be available. And that's where then we can start using those APIs to program your AQS, your ADS on disparate service provider networks so they can do the programming and provide the end-to-end QoE and diagnostics. So, so you see that this is not, we're not really starting from an empty slate. There's a lot of real-world deployments of this, and clearly it's possible to do in scale. Although when you think about it, it seems quite intimidating. It's like, how am I going to process all this data and make decisions in real time? What would it do to real-time traffic? Because it's not regular like your email traffic, or even for that matter, someone's talking about cat videos the other day. It's not really, it doesn't matter what happens with cat videos, but if you're doing telehealth to the home, it really matters, right? or time-critical applications, public safety applications. All of those have a real implication if you drop packets. So in terms of long-term vision of where the MEF, where we want to take this LSO work, what you've seen up until now is this portal exists at this level where a buyer who is essentially one service provider wanting to buy connectivity service from another service provider because they don't extend their connectivity all the way up to the end. So that model exists today within the MEF, and we have the LSO and the interfaces defined in these domains. But what we really want to do is take the LSO out beyond the service provider up to the end user, who in this case is the enterprise. So we're in the process of creating an enterprise advisory council within the MEF where we would have about 15 to 20 big enterprise end users who will be coming in and saying that, these are our pain points. So let's see how we can address those pain points with what we have in terms of those architectural constructs and the APIs that we've already built in the MEF, and sort of refine the roadmap in terms of what are the use cases that we deliver as a first set of use cases with this type of automated connectivity provisioning, service provisioning end-to-end. So just in the process of doing that. But some of the APIs, and by the way, if anyone's interested in this, I'd be more than happy to answer more questions on this. So this, I also said it's an education for me in classical music, because the theme in terms of defining the APIs, it's really, you can see it's like Presto APIs and Cantata APIs and Sonata APIs. So I looked it up and I was like, okay, now I know a little bit more about music. But the point is, so the LSO, this is the orchestration, and it has APIs south within a service provider domain. These APIs are called, or rather this reference point is called a Presto reference point, and this reference point, if you double click on it, it'll have many, many APIs within that reference point. The first one is a network resource provisioning API that essentially says that give me, using REST or RESTconf, give me 2 endpoints and I'm going to provision the right type of connectivity for you based on what you have specified in your REST request. So it's a very simple thing that we do today, and you can in fact see it running with Open Daylight using Mininet. But I think the possibilities are huge in terms of where it can go, with it. So today we are doing that over packet WAN, but tomorrow we also want to expand the scope to optical, and then going forward into other technologies like SD-WAN and 5G. So those are your Presto APIs. And then east-west, LSO to LSO. This is, let's say, Verizon trying to talk to AT&T, and they want to, set up a connectivity service end-to-end. So these are the APIs for that. How do I request for a service? How do I request a quote for a service? If there is a service disruption, how do I sort of deal with that? So all those APIs are defined here. This is called the Sonata APIs. These are also available in the MEF-Git, and obviously the reference definitions as well. And then there are APIs here to the web portal, and things like that. So there are some things that are not shown here in terms of some additional APIs, but I think really the point of this slide is that now we have a lot of these pieces defined and working, but we want to get that end user perspective in terms of which APIs or which services would be interesting from their point of view. I've spoken to many enterprises in the context of this Enterprise Advisory Council. And in fact, I was joking with Gort the other day, and no offense to enterprises if you're here. In fact, this reminds me of one of the presentations that I had seen in one of the conferences called OPNFV. But this gentleman, he's a CTO of Red Hat, Chris Wright, is that his name? So Chris Wright, he was traveling with his kids to the conference. He has 2 daughters. He was presenting, and in the middle of his presentation, he asked his daughters to step up onto the stage. And then he's essentially trying to make the point that, look, service provider, you might think that you're very unique and you have very unique pain points, but you're actually not that different. But he wanted to soften the blow a little bit, so he made his daughters say that our dad says that we are not very different, So I think that also applies to a lot of enterprises think that I'm in this business and I have very dynamic, scalable needs, but almost every enterprise does. So I think that's the beauty of doing this work in a standards, type of a work here because they all bring their use cases. We distill it down to saying that this tree at the top that's a low-hanging fruit, and let's just go with that. So that's what we're trying to do with the EAC, the Enterprise Advisory Council. If you are affiliated with an enterprise, or if you know anyone, please ask them to talk to me because we'd love to get them in on this dialogue. And if we got our pain points wrong, then they need to come tell us so we can, move the needle here with addressing some of this. How am I doing on time, by the way, Carol? Am I out of time? Okay, so I'm almost done. So the operating model, as I described earlier, is on the left is your committees in the structure of any SDO, standards organization, and the right is the code generation, entities. So we have 3 committees: the LSO committee, the one that describes those reference points and what APIs need to be in those reference points. How do you model them? How do you create the data models? How do you generate APIs from that? All of that work is done in the LSO committee. And then the services committee comes up with, it's quite fascinating actually, they come up with what are the new type of services that we could provide. I didn't talk about that earlier, but the MEF is one of those unique nonprofits that actually able to create an $80 billion carrier Ethernet market with all the type of, e-access, E-line, those type of services that we use today. And again, one of those, unique SDOs that took Ethernet out of the concept of a local network and expanded it out into carrier space. So I think there's something unique to do here to build on that foundation with network programmability. And then this is the new working group that we are committed that we're spinning up with the IMTC acquisition. And then on this side, you have the folks who are involved with code generation, the software developers essentially. And it's actually quite an interesting, mix of what happens when standards people come together with software developers. I've been in meetings with some very amusing comments, but it's really, I think it's really interesting because it's a very new world with these 2 entities, typically, vertical, but now working hand in glove. So we have the MEF developer community, Carol, that I was talking to you about earlier. We do hackathons, 3 to 4 every year. The big one is going to be in MEF 17 that I'll be running. And there are a lot of professional developers from companies, but there are also a lot of students. And this is a great opportunity for them to sort of, test out some of their ideas, either pick up a existing project or propose something of their own to familiarize with all of this with with SDN and FV, with 5G, all of these areas. We're all working in this space. And especially for this community, since you bring the application perspective to the table, it becomes even more interesting because now we can actually start fleshing out some of those intense stuff. And from the application and network, and then analytics back from the network to the application. So that's the developer community. That's the accelerator, the hackathon. And this is essentially where a lot of the modeling and the API generation work happens for the LSO. So finally, just hopefully leave a few minutes for questions. But so we talked about the Enterprise Advisory Council, and these services really all the companies who are participating in this work, they are for-profit companies, which means whatever gets done would need to have a market and would need to have consumers. So that's where the end users or the consumers become important. That's where the Enterprise Advisory Council comes in. So if you know of anyone who is relevant, or if you are part of anything, just please talk to me, because again, I don't think we should be doing this with the service providers and the vendors, but the enterprises need to be part of the equation, and maybe going forward, smart cities and all that as we go into the IT space. The MEF developer community, if you're a student or if you're a professional developer, you don't need to physically attend the conference in order to participate in the hackathon. You can actually remotely participate. We run it across different points within the globe, and we have virtual collaboration mechanisms, and hopefully they'll work. But please join us there. Some of the projects have already been published, so I'd be happy to share that also with you. And then finally, this is the applications crew. You bring the application perspective. So come join, participate, add to the dialogue in the application space. So I think with that, I'm done, but open to any questions now or later.
Thanks. That was great. Question about the standardization. It was a few slides back, but it sounded like, I'm not sure what stage of standardization you're at for the east-west, north-south, and if it's a necessity now to take in each of the operators' domain. I'm sure they've developed their own categories, their own objects that define all these. Is there a necessity to have some new definition or a meta definition that ties those? I'm not clear what stage that definition is at.
So that's a great question, Carol, in terms of support for brownfield migration, because really all the operators who we work with, they all have their OSS, BSS systems, their infrastructure. And they're all actually in the process of modernizing their infrastructure. And this is a challenge also for them to see how they're going to make, SDN, NFV, intent APIs with applications work alongside their existing, stuff. So I guess in the MEF, we have the advantage that we can work somewhat from a clean slate as a starting point. So that's where we are defining some of these interfaces and the APIs. And by the way, there you'll also see this interesting model that sometimes specifications are written first and then the code is developed, but sometimes the code is actually developed first and that goes into specifications. So it's kind of an interesting mix of standards and APIs. But I think underneath, down below, operators are implementing their mapping mechanisms for their existing infrastructure to be able to speak some of these APIs. And in fact, I'm in a lot of these calls and I see that their wheels are turning and they're thinking about, okay, if I have this attributes in a serviceability API, what would that mean to the way I do serviceability today? How do I best translate that? And obviously, they are all trying to, they want to do it in a way that works well for them, but it also has to work well for the other service providers. So I think that mapping at that level is not something that we necessarily handle in the MEF because it's sort of a more vendor specific. I'd say service provider specific or vendor specific. But if there are interoperability layers, like in the Presto APIs, where you could have your traditional NMS system or your APIs coming out not of your SD-WAN controller, those are all abstracted actually from the service orchestration layer, and we are doing that within the MEF. So you kind of get a mix of both, I should say, depending on which layer of the stack you're working on.
Okay, thank you. Yeah.
So it's a little bit of a follow-on comment to that. I think because I've been working with the MEF for the last couple of years, and one of the things I think the architecture that Bithika explained there with all the APIs, I think that helps a lot in to make with the point that she made about the different stakeholders not being that different. Rather, maybe they're speaking different languages to some extent, right? So now there's this common model, common architecture that people can talk to. So just having that common language to talk about the problems and potential solutions, that helps a lot. A lot of those APIs were defined as reference points, but were underspecified from the point of view of implementing them. Right. And so I think what started happening then was, a vendor could come and say, oh yeah, we have Presto. It works at that interface point, and it's really just taking their existing product and mapping it to that. So I think one of the things we saw was, we need to get these well specified, but we can't wait for that to happen. We need to start having some code. We need to prove that this architecture works and that these APIs are usable. And so that's where a lot of the stuff that Bithika mentioned on the right-hand side of that picture, the coding, comes into play, right? So we're creating reference implementations that support these interfaces, both to get it out there so you can actually use it, but to make sure that the interface is well specified enough. And those two things are changing in parallel. It's like an iterative process. We're not waiting for everything to be perfect. We're implementing it, feeding that back in, improving the specification, implementing it, and it's going on like that.
There was one other thought. Actually, in the IoT panel we had the other day, exactly what you said about the girls not being so dissimilar, but everybody thinking they're unique. They were decrying the fact that there are very few standards because everybody doing the implementations of smart, specifically with respect to smart cities, and all of the smart cities claiming to be totally unique, having totally different issues. And of course, it was clear to everybody who's actually working on IoT as opposed to smart cities how much they were similar. And I wondered if, in fact, where would smart cities, for example, fit into this, or would they, or are they, at what layer of your illustration?
Yeah, so I sort of look at smart cities. Remember, we showed 3 endpoints there, the enterprise, the residential, and the mobile. Smart cities, I look at that as sort of another consumer, another endpoint of that. Smart city applications, a lot of the public safety, let's say online lending library, or your public education, I mean, those type of applications, smart city specific applications would potentially have some instances running in the cloud, but some also running very close to the edge point of presence, because you want to do real-time processing. So edge analytics, it's another very big thing. So, but the network is still in between, regardless of which POP your application instance is running in. So I kind of see that as one additional consumer entity that would kind of show up or pop up at that very left-hand side, alongside your enterprise, your residential. But they would probably have, again, I should see that the intent APIs would probably be evolving to account for, the IoT applications. And really for IoT, so much of it is analytics. It's how much data local data can you collect and process at the edge? And how much of that need to really be shipped back to the cloud because you do not have enough computing capacity or power. And the network is right in the middle of it. Those islands of service providers are right in the middle of it, so the same construct should really be able to scale to those requirements also. Okay. Excellent, thank you. So I think you're getting ready to go for lunch right now. Thank you.
Okay, we have lunch, and it's going to be box lunch, I believe. So it's make your conversations over your box lunches and join us there. What? Oh, it's in the usual place. People who would like to, I normally at the end of the conference, if you want to come see the real-time communications lab over in the tower, it's 2 blocks south, and after you get your box lunches and have some food, if you want to walk over to the lab, we've been storing some things for the conference there. It may not be as impeccably clean as it always is, but you'll get a sense of what we do. We've expanded since you may have visited it last year. So we've now got a real workshop full of IoT gear and so forth. So if you'd like to come and visit, just at the end of lunch, maybe in about 45 minutes, I'll wave my hand. If you want to come over and have a look, I'll lead you over there. Okay. And thank you.